Okay, I can see that now the recording has started. So, hello everyone, and welcome to the second session. Um, so, um, I hope that I hope that you all managed to get the email with the instructions how to set up your Python installations and install the necessary models. And I hope that you all got the session 2 um, exercise. At least it's just what you guys got is the exercise that you guys are after this session. The idea is for you guys to fill the missing gaps, and I will provide the solution at the end of next week. Okay, before this next session. So on this second session, okay. Well, this here should be session. Sorry, now I just noticed that there's a session. Okay, yeah, fine. Um, yeah, like I was saying, so the first session, the one that we did 2 weeks ago, it was just an introduction session, so about why we should scripts, what are the advantages. I mean, we can do things manually, but why should we do things manually when we can push the boundary and maybe try to save some time in doing things automatically, things that we don't want to do ourselves all the time. Okay. So for this second session, is going to be more focused. Now it's going to be more practical demonstration of using of Python in Plaxis application, and it's going to be focused more on input scripting. Okay. The third and first section is going to be focused on output, on the output, and for the output, we're going to use the model that we are generated today in this session, in the input, is going to be used also in the third and fourth session to extract the results. So what is the goal today here? The goal today is to trying to reproduce a Plaxis 3D model of a PAL, let's call a PAL raft foundation example, okay? So you should get something. I mean, the idea is I'm just going to open a model that is already being generated before. Okay, so the whole idea is to model a 3D model like this one here. Okay, which we have a bunch of piles. I think it's 80 piles if I'm not mistaken. Yeah. So and we have a raft. Let's call it. We display it. We have piles. Let's call this part in the center. There's a part. This is going to be like a core, and the remaining part is going to be the raft. And of course, because this part is going to be more heavily loaded, we are assuming like piles to be longer. Okay, so we are going to have piles with bigger diameters, like 1200 diameters, two levels. So if we assume this, so if I now go to here to the ground model, for example, so the ground model starts from 5. It's the typical ground conditions in London, that as an example. And just by the way, the example I presenting here today is just a fictitious example. Is not based on any project or anything. It's just create these examples just to demonstrate to you guys that if you have a geometry that there's a lot of uh, uh, variety of geometry, if some paths are longer than the others, and you don't have any consistency in terms of length, that's where you should use the scripting. But anyway, like I said, these are London conditions. So we have the typical McGround gravels, London clay, and then Lambert group and tenant sands, followed by chalk. Okay. And of course, I mean, the whole idea here is that if we have a power raft and we assume that most of the load is going to be applied on the core, so let's call this small rectangle here the core, right? The core area. This is where we expect most the piles to be longer, and the more far away we get away from the core, we are assuming that okay, well, we're assuming that the piles reduce in length and in diameter. So we have 1200 piles, 1200 millimeter piles. We have 900 millimeter piles and 750s. Okay, with different lengths and diameters. Okay, so of course, I mean, we have this, and then we have the model ready mesh, and in here we're going to follow a typical construction sequence, which is going to be an initial phase using K-knot procedure. Then we do a pile installation, so which is not being visible here because we have the soil, but if I hide the soil, right? We have the piles here. Then we construct a raft, short-term loading in which we apply a certain load, more load on the core, of course, and then a long-term. Okay, so this could be done manually, of course, but what I'm going to show you today is how to set up this model without you press any button in Plaxis. It's just used by essentially doing everything with Python commands, okay? In order to assist on this, you probably all got this Excel file here, okay? So if I open this Excel file here, this Excel file contains all the basic information we need to build up this model. So we have on the first tab, we have the soil parameters. So everything is going to be more coulomb material. We have which color we should use, the elevations, the stiffness, the friction angle, etc. The pile layout, it's also specified here. So like I said, we have 80 piles, okay? And here we have what are the coordinates of the piling plan, the diameter, the toe and the top elevations. Also the raft, what are the coordinates of the raft, especially of the main raft and the core raft, okay? And finally, and this is also important, we have also a bearing capacity data because these piles that we're going to model, we're going to use embedded bead piles, so we have to specify the bearing capacity as an input, okay? So let's get started. So before you start, if not sure if you guys already tried from your end, but I suggest that when you open this script, Jupyter script, make sure that the Excel file is contained in the same folder as the Jupyter notebook, okay? And the reason is that because throughout the procedure, the coding, the script procedure, the script will need to get information from this Excel file, and in order for this to work, the Excel file needs to be in the same folder as the script, okay? So let me just close here again and try to open this. So to open the script, what I do is I'm going here to Expert, Python, then I'll put Jupyter Notebook, okay? Now, there will appear, for you guys, might appear a window to activate the server. So if I just go here to the server again, so make sure that the passwords, I mean, I have this password, but feel free to put whatever password you want, but just make sure that on the script, the password is the same, okay? So I will show you now where this can be changed. So if I just open now the script, now it's going to open. Okay. Now, let's get started. So the first thing we want to do, and the first thing we have to do, we have to initialize the Python models that we want to use in this script. Now, for this script, a part of the typical Python models that is used, that are using by default, there's a specific one we want to use that is pandas, which is going to be used to not only to access the Excel file data, but also to do some manipulation on the tables, on the data frames that we exported. So we need to go there to extract columns, to apply, to multiply values on the columns, for example, to transform, for example, multiply passing from meters to millimeters or millimeters to meters, etc. So we need to the first step is, okay, let's import that. And the way we do it is, assuming that you have already installed pandas, based on the instruction I send you in the first session, the only thing we have to do is we have to write import pandas as PD. So for now on, so let me just restart this, just clear the output. Okay, so a way is, I mean, I'm not going to run the script all at once. I'm just going to run cell by cell so I can demonstrate to you guys how this is going to work, okay? So to run this, I press Control Enter, okay? So it's running out. So 1, the first operation be run. And now we have a variable called PD, which is a pandas model. So from there, then if I now put dot and then press tab, you can see there's a lot of methods that can be initialized. So all these methods are methods that are associated to the library of pandas. Okay, fine. This one is just some. This one is not in your scripts, but it's just for you guys to understand what is this line here. This contains the functions that are supposed for you guys to figure out for yourself after this session. The ones that are in the missing gaps, on the gaps to fill the code. So these kind of import these functions that is saved in a different file. And like I said, after this session, and in the next week, I will provide the full script with the correct code. But for the purpose of this presentation, I'm importing this so we are able to run this. Now, next step is to run the boilerplate. So this boilerplate, basically, what means is this is what will make the connection between the Plaxis and the Python and the Jupyter Notebook script. Okay, so it's always the same bunch of code. Okay, so you just have to make sure that, for example, if I go back here to, let me see if I can put this side by side. Okay, I think that's better. So if I go back here to remote scripting, you remember that there was this port, right? So we have to make sure that the port number match. Okay, my suggestion is always keep the default one, because if you keep this default one, then when you open the output, you're always going to open with this is 10,001. Okay, the password, just make sure that it's the same as here, and that's it. So if we now, I just have to run this one. Now run this one here, and just take us some time to run. Okay, so it's run. So now what happens is I define the global and the server parameters, both for input and output. So S and G refers to the input program, and S underscore output and G underscore output, as you can imagine, refers to the output. And how do I know that? Because if I do this, now if I try to see what is G, if I try to call the G variable, it's just going to say global object, okay? But if I do type, there's a command in Python called type, and then you put an object inside, and it returns what is the type of object that we have inside. So you see that if I try to figure out what type or what type of object is this G, you see that it's an object that comes from this Plaxis script. Okay, so you see that we're importing a library that it comes from the Plaxis itself, and inside of this library, let's say, or a model, it has all the code necessary to define this global variable. Okay, and also if I do with S, same thing, is the server. Okay, so moving on, now that we have our Plaxis and the script connected, let's get started now with the next step, which is, okay, now that we have this, let's go to let's try to see if we can access the Excel file that is saved, that contains all our input data. Okay, so the way to do this is, like I said before, we have to use pandas, and in order to do this, okay, so yeah, we have to use pandas dot read underscore Excel. Okay, and a good way for you to understand which tools or which method or attribute you should use, a part of the documentation. I mean, there's a good documentation in pandas. So for example, in this website, if you want to learn more about the pandas library, you can access this website here, and there's good documentation, or you can also access the documentation here, for example. So if I now put like this, like if I can see all the methods that is associated. So in this case, is the read Excel, right? So if I do now read Excel, and then I do this, okay? And now if I press Shift Tab, I can see the documentation here. Okay, so I know. So from here, if it is a command that I'm not so familiar or I don't know exactly what attributes I have to or variables I have to put inside of this function, then I know that okay, I have to put here IO. What is IO? To say is IO is the name of the Excel file, right? Sheet name, which tabs. So basically, what we are saying is we have to tell which tab we want to import it. In this case, we're going to import everything. So you see that if we go to sheet underscore name, it says specify no none to get all worksheets. Okay, so that's what we're going to do, and that's what is here. So we have here the name of the file, Excel file, and on the sheet underscore name we put as none. And if we do this, let me just copy this line of command here, and now if I copy paste this, okay, and now run it, what we get is not a table, but we're going to get something different. Okay, what we're getting is a group of tables, a group of data frames that they are stored in what we call. So if I just call this, let's say, if I put type a dictionary. Okay, so for those who don't know what is a dictionary, it's a kind of a list which basically works as a dictionary. So you have to provide a key. If you provide a key, it's like when you go to dictionary, you want to find a meaning. If you want to know the meaning for for what is an apple, you go to Apple and you get the correspondence. So it's more or less the same thing. So if we now do this, if I just go back here, we see that we have a key. So the key is the name of the tab. Okay. So it's all parameters, and inside of that key, we have a data frame. If we go to the berry capacity, so berry capacity here, we also have that. Oh, all do I know that this is a data frame? Because if I run the loop in which I ask to print the type of each one of the values for each key, okay. So if I just run this now here, okay, fine. If I run this to print, um, we know that we have 4 keys, and for each 4 keys, it's associated to a pandas data frame, okay? And each data frame is basically the values here inside of these tabs, okay? So this is important because this is how we are going to access from now on. This is how we are going to access our information, okay? Because now if we have a key, if we have this as a dictionary, so if I go back here and they say df underscore all, and now I know one of the keys is all parameters. So I go here, let me just copy paste this, put this as a string. If I run this cell like this, it will give me back a data frame. Okay, so this data frame is basically this information here. Okay, and also keep in keep pay also attention to this none a number. Okay, so basically what means is because on the Excel we have empty space, so the program is say, well, there's no number here, so it's nothing. So and we're also going to see how can we deal with this, because we need to do some cleaning on this data frame in order to remove this not a number here and substitute with something else. Okay, so now that we already import all the data and input to data and everything is saved in a dictionary, now the next step is, okay, we have the input, let's start to build up your model. Okay, so the first step is, as you all know, the Plaxis workflow. The first step of every Plaxis model is to set up the model, the cell model. Okay, so we go to the cell tab here, right? So if that's the case, then the information we want to access from the input is the cell parameters, because that's going to be the important information that contains the elevations, the salt stratigraphy, the properties, etc. Okay, so let's do this. So we know that this is the way to call it. So if we do this, if I just run this now, okay, I went to the dictionary, grab the data frame of the corresponding subparameters, and save inside of this variable called df underscore soil. Okay, Okay, but we still have these not a number stuff there. So the way to do it is to use a function in pandas that if we call the data frame and put a dot and you fill this with fill NEA, and now let's see the documentation on this. We can see the documentation and it says here, fill not the number values using a specific method. And what is the method? We are telling that we want to replace the not number with a certain value, which is going to be 0. Okay, and we put in place equal to true. Basically, in place equal to true is the same as this. So instead of me doing like this, okay, instead of me evoking the data frame 2 times like this, okay. So if I put like this and I'll just remove this command and this command, they are the same thing. The only difference is that when you put in place is true, you don't need to put an equal, you don't need to do a logical operation, say that variable is going to be equal to the same variable, but without a certain value inside, okay? So that's pretty much the same thing. Okay, so if I run now this, now you see what is happening? Everything, it is not a number, they were all replaced by 0, okay? Which is what we want, because at the end of the day, because if I was going to run this without replacing this, by the time I was creating the properties, the script will try to input this not a number in the Plaxis, and Plaxis will not like that. Okay, fine. So we have already our properties input. Sorry, we have our input data already saved in a specific variable just for the soil. Now is the time to generate the borrow. Okay, so first step is let's go to the soil mode, which is already here. Okay, so but by the way, I have an empty model here. Okay, so I'll just run this. Okay, move to this. Fine. Then the next step is to specify the dimensions of the model. So it's the same thing as going here, project properties, and then we have these dimensions here for the contour, right? So we are defining that it's going to be we're going to define our model dimensions to be 80 meters minus 80 to 80. Okay, so if I do this, run, you see, all right, and keep in mind, one thing I want to point out now is have a look on the similarities of the Python commands and the commands that are generated in Plaxis. Can you see the similarity here? It's the same. It's there. It's quite similar. What you have to do is to call the global variable, the one that we define here on the top. So let me just move here. Yep, this one here, the global one. We put dot, and then what we have to put here, we have to put sol contour, and then we put the initialized rectangular. So you see that it's quite the same. It's just flip, but instead of being initialize soil contour and then the coordinates, here is soil contour, then dot initialize rectangular and then the coordinates. And of course you have the bractless here and the comments, which you don't have, but you can get the idea that if you already know what is the command in Plaxis, then to figure out what is the command in Python, it's almost straightforward in most of the cases, and you might get it there with 1 or 2 tries. Okay, so fine. Now that we define the contours, next step is now that we have this table here, we have to define the source photography. Okay, so and the borrow, of course, but in order to define the borrow, we have to go to this table that where we have saved the sol information, and we have to extract the information of the elevation on the top and the bottom. Okay, so how do I do that? Simple. I will call this data frame. Okay, and then I put square brackets, and then I put the name of the column on the top. Okay, if I do this, just I'm going to copy paste here. and I need to put this as a string. Okay. So you see, it returns me this column as a panda series. Okay, a series is a panda series is basically imagine a data frame with just one column. Okay, it's basically that. Okay, but we don't want this as a series. We want this as a list. So we put that a method to do list. If I do this, then it returns the list. Okay, so we have all the information here sorting in the list for the top. Same thing for the bottom. Okay, for the bottom, then I just have to put the name of the column for the bottom, of course. Okay, we have all this information here. Okay, let's create the borrow. The borrow is by running this command. So if I run this one here, let me run this. So you see that to initialize a borrow, if we want to generate by command, you just put borrow and the coordinates of the borrow, which is pretty much the same way we're doing here, with the difference that we just put the global object and then dot, and then we put the Plaxis command. And then I'm telling I'm telling that the water level, the phreatic level is located at elevation 1 MOD. Okay, that's pretty much what I'm doing. So if I now go here inside, that's what is here. So they add this one. At the moment, we don't have nothing in terms of self-stratigraphy. Okay. Now, to create the sol layers, this is the part that we have to resource to some repetition, because it's always going to be the same repetition. You have to click the button, put the values, create another layer, put the elevation, and so on. So in order to do that, let's use a loop function here, a for. So what I'm saying is, for a range basically kind of creates a list of sort numbers. So it starts from zero. So if I just copy paste this part here, okay. So basically, if I do this range, it's going to be range 0 to 7. So it's going to create increment numbers that start to 0, and finish in a number before 7. So it's always going to be incremental unit every unit. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 6, and it never goes to 7. And why we do this? Because our column has our data frame has 7 rows, right? So it starts from 0 and finish at 6. So by doing this loop and iterate, so what we are trying to do here is iterate for each row. So it starts at the row 0, okay? And what we're going to say is, okay, we go there. I want to access the borrow, and I'm putting here an if command, say that, okay, by the way, if I'm in the first row, which is going to be the top layer, I want also to define, because if you all recall how to define this in Plaxis, you add something here, right? And then you have to put a value, let's say 5 and then minus 10, right? But then if you put add, the top is already like the same as the bottom of the previous layer, so you don't need to specify again the top. So let me just delete this. So the whole reason of putting a if here is just to say, well, if it is the first layer, also define the top one. Otherwise, just define only the bottom. Okay. Only, but you don't need to specify the top for the remaining ones. So what it's going to do on the first layer is going to say, well, it's going to be 5 elevation, and then it's going to grab on the bottom strata 1. Fine. You finish that, and then it goes to the next row, which is going to be the gravels, and it's going to be top 1. So top 1 is already assigned automatically, so you don't need to specify again. It only needs to specify the bottom. So if we do this by running this, now let me just run this. You see, everything is already set up. Okay, with just a couple lines here. Okay, so and then we go here, and we have everything accordingly to this information on the table. But we are not done yet here. Okay, what we are missing here is the material, is the properties of the soil. So we have the stratigraphy, but we still don't have the properties. Okay. Okay, so the next step is create a material set and then assign this material set to the respective soil layers. Okay. Now, one thing I would recommend you guys to do is if you want to get more into this and trying to understand what are the commands, what are the options for each Plaxis command, what are the options, the variables and the attributes or what exactly you can manipulate in the functions. I will strongly guys you recommend to go to the command reference here. So if we open this, for example, now if I go, for example, on to create a material, we can use a command that is called soil mat. Okay, soil mat. So I think it's here, soil mat. No, sorry, it's not this one. Sorry, it's this one here. So so if we go to soil mat, yep. Here you have the documentation on how to create a material. Okay, using command lines. So if you call this soil mat, okay, and then you have the properties and the description for each property. So if I assign a property called name, the function knows that I'm assigned a name. If I put the soil model, and then you have different soil models here. And by the way, you don't need to specify the name of the model. You can specify by number. So if you consider this ordered by 0, starting at 0, so this is 0, 1, 2, 0, 1, 2, 3, so on. So because we are assigning more column, we are going to assign 2. Okay. So the whole idea is that now that we have this, if I go back here to the data frame with the soil properties, we have the properties here. Now what we want is to iterate each row, and for each row, the this function somat, it's already specified for the right parameter. So you have to go to the documentation and see which parameters you want to assign, and then you just put. So the way it works is you put the property and the value, then property value, and so on. That's how it's sorted out. Okay, so identification, I put the soil type is the name of the soil. Soil model, like I say, small column is going to be 2. Drain typage is going to be this column here. So as you can see, I'm saying with this command here, I'm saying that with this piece of code, I'm saying that I want to go to this data frame. I want to go specifically localize on the row that I'm entering. So if it starts, for example, at 0, so it goes to this row and it goes like this. I know I'm in row 0 and then here, so he knows he has to capture this value, drain. Okay, so it's going to be drain, and also the remaining parameters. You have stiffness, the strength parameters, the keynote values. The only thing that I just realized this later that I forgot to put you the Poisson ratio. So the Poisson ratio, just for your reference, is not in your scripts, but it will be on the final script. To put the Poisson ratio, let's assume that all the Poisson ratio in here is going to be 0.2 for all materials. Okay, so it's just put new, comma 0.2. Okay, if I do this now, okay, it will create a material set. And then what I'm saying is, because I ordered this before the soil layer, so this first soil layer is going to be saved on soil layer, say in index 0. This is going to be index 1, index 2, and so on. Then after I create the material set, I will tell, okay, I want this material set that was created, and I'm saving this on a variable called mat. I want this soil layer to be assigned to the material set that I just created. So if I do this now, there you go. And if we and just to make sure that we are doing this correctly, let's have a look here for one of the properties, for example. So we have London clay. We said even the color. We said that we wanted. I mean, you don't need to specify the color. It's not mandatory, but if you want a certain color to be assigned, it's good. It's a good practice to assign, and the color I think it should be here. Yeah. Okay. So we have the unit weight is 20, should be 20, yeah, 20. And then Drain Young's modulus is going to 68. Poisson ratio 0.2. What else? Yeah. Then we have effective equation 2. Friction angle. Yeah, friction angle 22. And yeah, so it seems to be okay. So assuming that everything is fine. Okay, so that's fine. So now with this, we complete the saw mode. Okay, now we have already our saw ground model. Now the next step is to move to the structure. Okay, oh, sorry. I click here on the structure, but I want the script to do that. In order to do that, I will just do, and you see that to go to structures is go to structures on Plaxis. In Python, it's the same thing. You just put g dot go to structure, close the bracket, and that will move to the structures. Okay, fine. Okay, so now next step is to go to that, to go back to this dictionary that has all the data frames. And now we want to grab the information that contains the pile layout, which is the pile geometry data. And we are going to fill not a number with zeros. If I do that, there we go. In this case, I think there should be any not the numbers, but just in case it is, at least you fill with something. Okay. Okay, so now the next step is, okay, we have 80 piles, but we know that there are certain combinations of pile diameters and lengths. Some piles have the same length diameters, some they don't. So what we are going to do now, we are going to use um, a, a special operation in pandas, which is group by. So what I'm going to say is I'm going to identify all the unique combinations of piles that we have in this pile layout, and we use this by this group by function. So if I go here, see, so group, so basically it allows to group the data frame using a mapper or series of columns. I would recommend, if you guys want to understand better the group by, if you go to the documentation, you can see the examples and it's very easy to understand. But if we do this now, this is what we get. We know that we have one set of combination that is 750 piles with toe levels at 10 meters, and we have a total of 36 piles using this configuration. We have 900 piles with toe level and minus 60, in total 28 piles. And we have 60 piles that have 1200 millimeters and toe level at minus 33. And when you sum this frequency, so you get the 80, the number 80, okay? So this is going to be important because now this information is going to be used to create the material set for the embedded beam, because we're going to create an embedded beam material for each combination, okay, for each set of combination. Okay, so in total we're going to have 3 material sets of embedded beams. Okay, so now that we have this, I think this is the same command. Okay, now the next one is, okay, so we are have this. Now we're going back to that global data frame. We're going to extract the information from the barrier capacity. Okay, so we know what our base capacity, USF. The T-skin friction is already derived based on the USF. Okay, and of course we say that, okay, with what are the properties that has to be assigned to each pile. Okay, because here on this one we just have the coordinates, the layout, but we don't say what are the material sets that have to be assigned. Okay, or what are the colors of the material set. Okay, so now that we have this data frame, okay, now we have this data frame and we know what are the unique combinations for each pile. We need now, the next step is to run a loop 3 times, one for each set of pile. So it's here in this loop function here, okay? in which basically some of the parameters are fixed already. So we are assuming that the youngest models of the concrete is going to be 25 gigapascal. The gamma is going to be 5 because it's going to be 25 minus 20 because I mean we are modeling it as a stick. In reality, there's going to be concrete in a place where soil is being there. So the 5 is just the difference between the unit weight of the concrete and the soil. So 5. The behavior is going to be elastic. The cross section size. So if maybe it's easy to show this. If I go here, the new what exactly we have to input on the embedded beam. So the gamma, uh, the cross section section, we say that we want this to be solid circular beam, and then the actual skin resistance are going to be multilinear. All and stiffness of the concrete here. Okay, all this is going to be fixed. It's going to be the same for all the piles in this case. Okay, so let's just delete this stuff here. Okay. Okay. So if I do this now, okay, I can start to collect the information from the information. So I can iterate from this unique pile here. So this table here, I can say, okay, what is the diameter on the first row? The first diameter is going to be 750. Toe level -10, and then you can filter. So these masks here we see it's a special operation in pandas that what I want is now that I have this information, I want to filter this information here site only to represent the information that has diameter 750 and level at -10. Okay, so if let me see if I can just put this in a very quick way, just to show you guys a little bit. So if I do this now, if I say that the diameter is 750, the toe level is going to be much -10. Okay, just fine. Okay, then if I now put like this. So what I'm doing is I'm creating a mask. So I'm creating like this is the identical. If I try to get some analogy from Excel, this is the same as filtering the table. So if I'm trying to filter only to show the 750 and the ones that have the information that have the toe level lower than higher than -10. If I do this now, is here you only get all this information here. Okay, and you get and the whole idea is that because we need this information, this column for the actual skin friction, we need this column here. Okay, to represent this to represent the skin friction. Okay, as a multilinear. Okay, so we do this. So let me just delete that. Okay. Here is just masking. The M bearing is just basically collecting the value. It's just saying, okay, well, whatever is the final value of that filter, the final row of that filter table, just collect the end bearing from there. Then, of course, it extracts the actual screen friction, the color, and now the code to generate this material set. I'm not showing here. I'm just putting here some notes how to do it. You just have to use this command G embedded beam. So if I go here to the commands, so again, let's go here to commands. So if I go here, no, it's sorry, it's yeah, yeah. So I'll recommend you guys to have a look on this information here on the command reference, okay, and try to understand. Okay, if I have all these parameters, how should I populate this command? In the same way I'm populating this one when I create the cell properties, okay? And I have already here the function defined separately. So if I run this now, okay, and of course, I mean, don't worry, if you're not able to do this by your own, you will get the solution by next week, okay? And the other thing I would just recommend you guys is try to follow this name convention for the material set. So if it is a 900 millimeter pile with toe level -18, just put pile underscore 900 diameter underscore 18 toe. Okay. And this is important because this is the way we are going then to call the material set later. We're going to show this in the next cell. So if I run this, there you go. There you have it. You have all the material sets already created here for the embedded beams. Now that we have the material set, it's time for us to create the piles based on the data frame of this data frame, the data frame underscore pile. And for every pile we are creating, we are already assigned the material set. So you see here it's going to be a loop. It's going to loop throughout. It's going to iterate each row of this data frame. Okay. Going to extract the coordinates, the diameters, and the material set. So you see this portion here that says pile underscore, and then there's a backslash here. So that's why you have to follow this name nomination, because the program is expecting to get a material set that follows this convention here. Okay, so it will put the diameter. So what, for example, for the first row is going to be 750. So it notes that it needs to go to 750, and the tool level is minus 10, 10. Okay, so the only reason that there's no minus here is because it doesn't work the way the naming in Plaxis works. It doesn't work with minus values, minus symbols. So that's why you just have to put an absolute value. But okay, it's just a convention. So if I do this now, it's just okay. Like I said, it's going to create this. Also, what is important is going to name the pile with the correct name. So there's the name also. Okay. So at some point it renames. So there's here, yeah, this line, it renames the line with the name of the pile. And also it will save this into a list in which we are going to form a group in order to just it's just a convenient way that if we want to select only the pile feature in the model explorer, at least we have something already as a group. So if I do this, you see, now it's creating the piles. Take a bit of while now. Yep, here we go. So you can see that all the long piles, the ones that are 1200s, are here. In the middle are the 900 piles that are set at minus 16, and the ones that are more close to the edge of the rafts are the ones that are shorter. They are minus 10. And like I said, it's already group. So if it's already group, and the name of the piles is that, because you probably already have already noticed that when you create something in Plaxis, by default it is a line underscore and number. But for convenience, sometimes we just want to select the if I think as a good practice is always a good idea to name things with some physical meaning. And if I do this, then I know that if I want to select pile 28, I don't need to I don't need to figure out what is the corresponding name. I just select here, and it is pile 28 here. Okay, fine. So that's for the piles, but we are not yet done with the structures. We still have to define at least we have to define the raft and the loads. Okay, so for the raft, again, going back to that big set of data frames that contains all the input data, it's on the tab. So if we go to the input, it's this one here. Okay. So we call this, and there we have here the data frame that contains all the coordinates of the raft. Okay. We have the main raft and the core raft. The core raft is going to be overlaid to the main raft to be precise. But then this intersection will happen when we move to the one of these grid modes later. Okay. So what are now the next steps? Yes. So first of all, in the same way we did for the piles, let's try to find out what are the unique names for the rafts. Okay, it's the same thing here in terms of names. So if I just run this command here, and now I call this raft because I saved this into a list, of course. So I mean, this is quite obvious. We only have two types of raft here. We have main raft and core raft. Okay, but this is important because we're going to do a loop based on this based on these names. Okay, so just delete this. Now we have this saving into a list, and now what happens is it will first iterate over the main raft, and he's going to use is going to filter the information only to show the main raft. And then based on that information, it will build the raft. It will build the geometry of the raft. And also at the same time, it will generate the material set for the raft. So as you can see, I mean, same thing, quite similar with the soil and also with the bedding beam. And again, if you are not sure all the properties are called, again, always a good idea to go here to the command reference, and that could be, I think it's called plate mate. So it should be, yeah, that's the one. So you know that if you want to specify the unit weight, you know it's going to be the gamma, for example, gamma. Okay. Okay, so we have this. We also extract the information from this table, the coordinates, and now there's just one thing that needs to be done. Okay, the way we just specify create plates in Plaxis is if I do this, let's say let's try to do this, for example. So if or a surface for that matter, if I do a plate, okay, I create a plate, and then I have to put a corner. I have to put the first set of corners, let's say 0, 0, then second corner 1, 1, and then let's say 2, 2, and then I don't know. I'm just putting random numbers. I'm done. So if I do this, well, it's oh, sorry, this is a 3D. Sorry, so it's three numbers. Okay, then I put 0, 0, minus 1, then 0, 0, 1, minus 1, and then 0, 0, so 0, minus. So this is going to be the first property, the second one, and then let's put this 1, 1. Okay, let's create something here, very small, but as you can see, I mean, it's going to be like the first property, the first coordinate, the second coordinate, sorry, 1, 2, 3, 4. So we have 4 coordinates. But at the moment, when we generate this, we have to input the data in this way in the program. But at the moment, it's not sort in this way. So what we have is a list. So if I call this, right, if I just call this, which is going to be the moment. So if I just put like this. So we have the information like this. We only have the information sorted for each type of coordinate, but we have to put the first X coordinate, Y coordinate, and Z, and then that's for the first point, and then so on for the next one. So we have to aggregate it in the list, okay? And that's going to be a challenge for you guys to do it. So my suggestion is use this to aggregate these both intervariables and flat the results in another level interaction. So basically it's trying to obtain the flat list by combining 2 lists, or in this case it's by combining 3 lists. I have here the function, but if you follow this link in a Stack Overflow, and the reason I put this link is because if there's something that you don't know how to do it, it's always a good idea to Google. It's always good idea to go to Stack Overflow because it's a good source of information. Sometimes you will be surprised that something that you don't know to do it, most likely someone has already figured out how to do it. So yeah, if I do this, I have already the command defined here separately, okay? And of course, then I save this into a list, and then here it is, the command gplate, which is the same one here, and the asterisk, the star, is important because then I'm saying that I want to pass all the variables, all the values inside of the list, I want to pass into that function. Okay, if I do this, it will create the surface, and then of course, then I have to assign the materials here and change the name. Okay, so if I do this now, there you go. So we have here the main raft, we have here the core raft, and we also have the properties. Okay, so we assign this, and of course the name of this. So the name, what I did is I said, oh, I want the name of the raft to be the name whatever is in the table plus underscore surface. Okay, there we go. And now let's have a look here on the core raft. So it's just to have an idea what will be the output of this. So of this a flat list. So you see now. So for example, this is for, let me just see which I value it is. I think the I is going to be the core. Yeah, it's the core. So if I go back to the core, these are the corners of the core. So we have the first point of the X, Y, X, sorry, X, Y, Z, X, Y, Z. So you see, Z is always 5. But then you can see that is ordered already in a way that you will input this on Plaxis. Okay, and like I said, in order to order this in this format, you have to follow the instructions that is specified in this link here. Okay, fine. So let me just delete this part here. Okay, now load. That's the final thing before we move to mesh mode, the construction sequence. So the load, I mean, this is very straightforward. I mean, it's just create a surface load, just surf load, which is the same command in Plaxis. And I say that I want to apply this all over the main raft, okay? And then once I create the surface, I want to assign a value, okay, of 100 kilopascal. And then to create the interface, it's just neck interface, and then say I want to assign the negative interface on the main raft. We don't need to worry about the core because, like I said, when intersecting the model, it will automatically apply the interface to the core also at the same time. Okay, so if I do this now, you see, yeah, there he is. We have the load now, minus 100, the interface. So we are now ready to move to mesh mode. Okay, now for the mesh mode, what we're going to do here is, first of all, we're going to move to mesh mode. It's going to intersect the model. And then the rule here is that we want to apply a medium distribution, but we want to apply some local coordinates factors to the structure elements. And the idea is that on the core, everything that is in the core area, we want more refined, and everything that is more far away from the core is going to be less refined. Okay, so the core raft, we want this to have a coarseness factor of 0.2, elsewhere 0.5, and on the piles, what we are saying is if any piles have a length lower than 80 meters, we apply 0.6. So we are assuming that these are these piles that are located outside, so we don't care about if they're too refined or not. And if the piles have a length higher or equal higher at 80 meters, depends. If the diameter of the pile is higher than 1 meter, then apply very high local apply a strong refinement there. Otherwise, just 0.4. Okay, as you can imagine, this can be done by doing a loop. And the way to do this, again, this is part of the exercise, like part of your homework, based on what we already discussed before about loops, about ifs and stuff like that. The idea is for you guys to define a for loop that defines the correct local coordinates for different parts of the raft in the mesh. What the tip I give you is that use as a selection criteria for the raft, in a way to identify what is core, what is the main raft. Identify that any surface that has an area lower than 500 square meters, then is a core. Otherwise, is the main one. Okay. So again, I have the function here already defined separately. Okay, so already just already inputted on the script, and then so this is just sorry, my mistake. The homework is just for the surface. Okay, it's just for the surface. What is already here in the code is the embedded beams. So the embedded beams, you can see this is the for loop. So you interest all the elements of the embedded beam, and then you say, okay, if the length is lower than 18 meters, then 0.6. But else, if it is not the case, then it's going to check. It's going to check if the diameter is higher than 1, and if it is higher than 1, apply 0.25. If not, apply 0.4. Okay, and then after that, ask to run the mesh to generate the mesh with the medium distribution and view the mesh. So let's have a look here. So I'm just going to move the ears because I just want to hide this so you guys can see this in action. But otherwise, it's going to be camouflage. So let's say let's put like this. So let's go. You see that? I'm not sure if it is possible to see by the colors, but it's applying the local refinements to the piles now and it's generate the mesh. Okay, there you go. We have our mesh here. Okay, and let's have a look on the quality. Okay, seems okay. So far, for the purpose of this exercise, I'm happy with the quality of the mesh. So let's close this. Okay, we have our mesh generated. Now we come to the last part of this exercise, which is generate the construction stage. Now, the construction stage, like I said before, is going to be consist by 5 stages. One is the initial stage, initial phase with cannot procedure. Then pile installation, which basically we just activate the piles. Raft construction, activating the plates of the rafts, and then activate the loads on the short-term loading, and then long-term consolidation by running a consolidation analysis. Okay. Just by the way, just also keep in mind that on the solve properties we had to assign permeabilities. It should be. I'm not sure if we can see from here, but you should be able to see here. Yeah, we have the permeabilities here. Okay, which are important to run the consolidation analysis. Okay. So there will be some parts that you have to define yourself. We will get to that. Okay, so let's first start. So if I move now to stage mode, okay, so just move, create this, put like this. Okay, we have already the initial phase generated. We don't need to specify anything because it's the cannot procedure, so we use the default values. So let's first generate the pile installation stage. So the way it does is, okay, I ask to go to the go to stage, ask to select the initial phase as the current phase. So now we have visualized the initial phase. It's the only one, by the way. And then we ask to create another phase based on the initial phase. So the new phase that are created is going to start from this initial phase. So if I do this, it create a new one. So maybe it's better to do this in steps. Just so if I do this, okay, look like this, and now let's create this one here. So if you just copy paste, then see, create now a phase called phase underscore one. But of course, it creates this, but we are still not selecting phase one. So you still have to go here and say, well, I want phase one to be selected. You see, now it's phase one is selected, but we don't want to call this phase and this. We don't want to call this phase one. I want this to be called stage underscore one, for example. So we'll go here. You see, now it's changed the identification name. So for stage one, that's just the name. Sorry, that's the name, and then the identification is where you have your phase one is going to be this one here. Okay, so if I just run this, Now it passed to PAL installation. And now the last thing we have to do is just to activate the pulse, right? And to activate the pulse, we have to call the global parameter, embedded beams, and then activate it and say, okay, I want this to be activated at phase at phase one. So where you have here the G dot phases, and it's important the plural name here, phases, because it's the group of all the phases, and the index represents the order. So as you can imagine, the index 0 corresponds to initial phase, index 1 corresponds to this one, and then the next phase is going to be the index 2, and so on. So if I now let's just delete this. If I just run this, there we go. We have our first stage set up. I'm going to visualize now this just to be able to see the rest. Now, the next phase is to the raft construction. So now it's going to be a little bit almost the same thing. So the idea is now that I want to create a new phase, but starting from the previous phase. So it's going to be the index one inside of the group of phases. Then I want to select the new phase as an active, change the name, and now what we need to do is to activate the plates. So yeah, we have to activate the plates and this phase. So the way to activate, we have to activate this one here. But now, if I let me just run these ones, just for you guys to understand what is at stake here. So if I run just this piece of code here, okay, fine, generate, right? But there's something missing here, right? What about the core? I mean, the core is being set as main raft, right? I mean, we define the geometry of the core, but what actually did by define that geometry is just define when I need to set the model. Now I can select all in this part as the core, and all these remain. If I just hide this, I only have this part. This part is all in the main raft, and the other one is going to be the what? So yep. So I still have to change. The material set here at that phase in order to, I have to tell the program, okay, no, I don't want this to be the main raft. I want this to be the core raft material. So how do I do that? What I do is I will, because let's assume either I know the name. It could be a very easy way. If I know the name, how to call it, and bear in mind that when you move to stage construction, now you have these intersect elements. So it's not too big. So here it was called, let's say, main raft, but now when you move here, it has, because of the intersection, the name might be slightly different. So in principle, we might not know the name. So the easiest way to do this is to run a loop on all the plates available in that phase and check the area. So I say, okay, I want to see if the raft is an area lower than 500 square meters, then for sure is the core raft. So I say, okay, change this to the material set of the core. Okay. And if I do this, and it shows only two rafts, so what we're going to see is if I run this now here, there we are. It changed because that's the only one, and it's easy to see. So if I go here now, if I put echo, this one, and then area, I think should, yeah, you see, we can check the area here. This one is 200, and if I go here to this one this is 500. So that's the reason I use 500 is because I know that the main raft is a little bit above of 500. So that's a way to for the program to understand what is the raft and what is the main raft. Okay, so just let me just delete these ones. It's just now, and of course, then after the end, I have to activate the interface. So if I just run this, there you go, and just delete this one, just to, yep, that's fine. Now, just almost to conclude this, next stage is short-term loading. Okay, same thing as before. But now the only difference is now that we have to reset the displacements. So the way to do it is you call for the face. So it's now going to be the index number 3 inside of the face group. You have to call the deform attribute, and then inside of the deform attribute, you have to say reset displacement to 0 and set true. That will basically, it's the same thing as going here. You just click this button here, very much that. Change the name and activate it. Now, the challenge for you guys is to assign the right loads to the surface, because what we're saying is, and it's explained here, we want the core to be loaded with 300 kilopascal, and the remaining parts of the raft be loaded with the 1770 kilopascal. Okay, so the idea is for you guys to derive a loop function that goes to all the surface, check the area. If the area is lower than 500 square meters, is core, otherwise it's main raft. And if it is one or another, apply the right one. I think for all the information that is already presented here in this script, you should have all the information to set up this by your own, but I have already input here the function myself here. So if I just do this, there we go. Now this is 300 and this is 70, okay? And of course, it creates the short-term loading. And then finally, it's just the long-term. Long-term is just create a phase in which it's going to be a exact copy of this one, but you just set this as a consolidation, and we want the consolidation to run until a minimal access pore pressure is achieved of one kilopascal. Okay, so if I do this, there you go, and then yeah, and after this, everything is done, guys. Now we can start to run our model. Just to run our model, you can either put calculate or just run here. Okay, so yeah, so now it's going to run. Oh, sorry. Sorry, guys. Let me just. I don't know what happened here. Maybe because I just ran different commands at different stage, something didn't like. Let me just. Let me just run from here. Run below. So it says initial contains features of plate with no materials. Ah, I know why. You remember when I create that that fictitious, but yeah, it's this one here. Makes sense. That's why it wasn't working. So yeah, but now I have to generate everything. Let me just, what I will do is okay. What I'll do is I will create a new project just to guys to have an idea that, I mean, we did this step by step, but now if I just ask to run the script all together like this, just run all. So it should start to kick in, and then it's just a moment. Yep. So any questions so far? We can take now this opportunity to open the question sessions, I guess.
I have a question.
Yes.
I was wondering for that, you told us to go on help and do command reference, but I can't see the same, like when I open that, I see like a blue website instead of what you have. I don't know why.
So you're saying with so you say well no but no command reference here, right? This one here.
Yeah.
Okay.
I don't see
And
that.
okay, I mean the probably it must be something with because what it does is it opens a file that is located in so you see the link here, this link
Okay,
here.
HTML.
It tries to
Okay.
open the HTML
Yeah.
page. So I would say maybe check the installation in your Plaxis to see if that file is there.
Okay.
Otherwise, you might need. I don't know if your Plaxis is installed by yourself or is if it is a company installed by IT or something like that. So that will be my recommendation
Okay.
to check that.
Sounds good. And can you just show me how you went to that one that you were using for the soil mat? So if I were to open that, input command
Sure.
reference.
You have input and output.
Yeah.
There's the commands. The commands is just to create geometries, and then if you want to
Yeah.
specify properties, it's this object reference here. Okay,
Okay, object
and
reference. Okay, got it.
yeah, and also another thing that might be useful, but I'm just have to wait. I mean, I can stop the calculation here just for a moment and restart the calculation. Another thing that is worth it to mention, there's also this scripting reference. Okay, so if you
Mm-hmm.
open this scripting reference, it's also a good source of information that if you don't know how to do a stuff or you have no idea, I mean, you want to do something but you don't know how to do it exactly or how to call this in Python. You know how to call in Plaxis, but you don't know how to call in Python first because sometimes it might be slightly different or you have to invert the numbers or something or the commands. You can go here, for example, the Solmat. If I go to Solmat here, then it provides kind of some examples of commands for Solmat. You see,
Okay. Yeah.
so it's also a good source of information.
Okay, great.
Okay.
Thank you. And I have one more question. For when you were looking at Jupyter Notebook, you were showing us like if on pandas, how do we add methods? So it was pd dot and then tab, and then it showed us all the options, right?
Yeah. So
And then you did something, I missed it. You did something where I think you did shift something, and then it showed you what you could fill in. Can you go over that
yeah
one more time?
yeah let's give an example. Like for example, if I want to create an empty data frame, let's say I put data
Mm-hmm.
frame. I put the command and then the
Yeah.
brackets, and now if I press Shift Tab, it
Shift
appear
tab.
it
Oh,
appears
okay.
it
Shift
appears
tab.
here it will show me the documentation.
Yeah.
This is the same documentation you will find if you go to the Pandas website. It's the same
Okay.
documentation, more or less the same documentation you find there, but it's just a convenient way that instead of you going back and forth to different websites or with different pages,
It's a
you can
shortcut.
yeah, it
Okay.
helps to understand that sometimes with these things, it's I mean, it's so much variable, much code that you have to read, and that sometimes it's very easy to forget, okay, well, what exactly it's called a variable, because sometimes you have to put like, okay, data equal. I mean,
Mm-hmm.
you might not recall, so it's an easy way to remind ourselves what are the inputs, the necessary inputs to run the commands.
Perfect. Thank you.
So let me just maybe just restart here the okay, just I mean. So basically, I mean that this it is. So what we're going to do next with this model is just we save this model and we're going to use for the next two sessions. We're going to do the extraction of the results and the processing based on this model. So just don't forget to save the model on your end, okay? But anyway, what I will do is next week once I when I provide the full script, I also provide a copy of this model for those who struggle who didn't manage to make it to work from their end.
Hello.
Yes.
Yeah, Francisco, just one thing. I have received this your file for setting up. There's a sample file which is in I think is in a version V22, but our company just have a slightly older version. It's still V22, but we can't open to the version you have. I'm wondering, is it a way that we can convert it into an older version? Because at the moment, I can't find a way around this.
Yes, I think someone else has also the same problem. It's one of those things because I think my understanding is that although it's the same major version, usually between minor versions, if it is 0.1 or 0.2, it should be a problem to open between models. But for some reason, in this package 22, you cannot open. If you create something in version 0.2, you cannot open 0.1. But what I can do, I can provide a list of commands to replicate the model. It's just very straightforward. It's just a couple of commands. I can ask Palak or Annabelle to send this to everyone at the end of a session.
That would be great. Yeah, we can
Yeah,
start from that.
Yeah, but the whole idea of that, Joanna, it's just, I mean, it's just a test. It's just to test to see if the models are correct.
Yeah.
But we, I will ask them. I will ask Arabella and Palak to send this to you guys.
Yeah, sure. Thanks. Sorry, can I have another question?
Sure.
Yeah. Thanks for presenting this. I just thinking, I have received a recording and the presentation. If someone from my company is interested, can I just share to them? Would you mind? I share to a wider audience.
I mean, I don't have any obsessions. I think that's more a question for Arabella and Palak. For me, I don't have any obsessions. No.
We expect people to share things, so yeah, no issue with that.
Yeah, thanks.
Okay. Anything that you guys would like me to clarify better about the scripting, or especially on the parts that you have to do as a homework?
I have something. If we have a question while we're doing our homework, can we contact you some way, somehow, or do we just wait until our next one and we can ask you the question?
I mean, I think you can send you can send an email if it is something that is very straightforward to answer very quickly.
Okay.
I think it's fine. Otherwise, I would say that, I mean, I will provide the final the final script next week.
Perfect. Thank you.
So yeah, so it has already run the model. Yeah, as you can see now, I mean, we have the model here and we can open the model and inspect it. I mean, of course, I mean, I would say that most of these scripting things for input, I mean, the major advantage of scripting is more on output and post-processing. In input, there are some advantage to do this, especially if you have, let's say, if you have to, like an example I provided in the last session, if you have to do a PAL calibration, you have to run models multiple times. It's better to have something that changes the parameters. But to set up models, I mean, if it is one-off, I mean, you don't need to do that. But I think the idea, I think the only thing that probably here it benefits most the script is the piles, because it's 80 piles. So I mean, you can, if you know how to do the commands, you can always go to the Excel and try to replicate the commands. But if it is like a large project, or you have a piles with different lengths, and then you have to specify different properties and stuff like that, and you can easily end with different, I don't know, 20 or 30 different combinations of pile diameters, lengths, and toe levels and tops. Yeah, I mean. Okay. I think we're almost reaching our time here.
Thank you very much. I'm going to ask. Yeah. So Palak, stop the recording. Thank you very much for your time. I think it was a bit too quick for me, so I'm going to rewatch it. And
yeah, it's
no, it's
in
good. It's
1 hour,
good.
1 hour, 1 hour and a
Yeah.
half. Yeah, it's that's why there's a recording.
Yeah. No, it's good. It's good. So thank you very much. And yeah, I mean, if anyone has any questions or problem and they want to contact us before contacting you, we can compile all the questions and then send them through. I think it's going to be maybe easier. So yeah, thank you. So for the homework, it's only the mesh in this.
No, it's going to be let's see, there's this part. I think it's what was it was says here this one for the bedded beams,
Okay.
for the bedded beam materials, the mesh, and the loads. Assign the loads. Yeah.
Perfect. So perfect. See you all in 2 weeks then. Thank you.
Okay.
Thanks.
Thank you. Bye bye.
Bye bye.